All right, sorry about that. I got a phone call. Kids want to connect with other kids. This school out is like free time for everyone. Okay, so we've got 0.55 is the constant times 24 ounces times our percent alcohol. And we're going to divide this again by the body weight. We're going to take a different body weight though. Let's take 135 pounds. And we're going to take that same 4.8%. Sorry, 4.8%. And if we go ahead and do that, we take this 24 ounce, so 2 beers at 4.8% per beer of alcohol for a 135 pound female. Take a look at this. It's actually going to be about 0.03, which is the same, about the same blood alcohol content for that male. It's slightly different though. She's at 0.02931, so she's at a slightly, well, she's slightly closer to 0.03. I had to do less rounding for her. But they are probably, well, more comparable than we thought they were, right? So males and females, you do have more comparison than you thought for how quickly we take in, even though we have different amounts of fat and different body masses and different rates of absorption, they still are pretty consistent in the amount of the amount of absorption. All right, and then the last little bit that I wanted to talk about is this right down here. And I know that the note packet keeps going. I'm not going to talk about alternate pathways. That's just something we're going to drop today, okay? Because you know, that's sort of an extraneous topic, and we're all learning from home, so, or trying to. So down here at the bottom, ethanol breakdown is accomplished by a series of enzymes. The amount of these enzymes and the efficiency of these pathways varies among people. We have different amounts affect people differently. And it's because we have different genetics. We're just different. So we have different ethanol processing enzymes. We have different amount of enzymes. We have different genetic makeups. We have different liver health. A healthy liver can actually process 1 drink per hour, whereas a damaged liver can process less than 1 drink per hour. Okay, so if somebody has an unhealthy liver, if they've been drinking a lot, and their liver is not healthy and they continue to drink, that liver is going to be slower in its processing, and their alcohol will stay in their body longer before it's metabolized. And then the last concept, this actually is going to help you a lot in the lab that I gave you. So I wanted you to focus on this for the lab. All right. And I know this is a little hard to read, but hopefully once you do this, the lab, I think that will help. All right. So the ethanol pharmacokinetics, the metabolism. 2 pathways are involved for this oxidation of alcohol. So 2 liver enzymes are involved, and this liver enzyme is alcohol dehydrogenase right here. Whoops, sorry, not on the screen. Alcohol dehydrogenase is one of them, ADH, and then aldehyde dehydrogenase is this one over here, or ALDH, aldehyde dehydrogenase. Some of the alcohol dehydrogenase is found in the stomach, which is why 25% of the alcohol is broken down in the stomach, but most of it is broken down in the liver. And so that's why most of it is broken down in the small intestine, eliminated in the liver. All right. All right, so I'd like you to be familiar with this pathway over here. So I'd like you to be familiar with this ethyl alcohol right here that actually is broken down with this alcohol dehydrogenase. So you're actually watching these break down. Your NAD creating energy in NADH, and then NADPH losing energy by dropping down to NADP. So we have some different molecules being changed here. And then it makes acetaldehyde, which is CH2CHO. And then it's further broken down until it's an acetate, which is then when it's going to be removed. All right. So it's the ADH, the acetaldehyde, and then the acetate at the end. All right. The last is NAD plus this H, producing lots of this NADH, which is an energy carrier. This is actually the energy. All right, this is the energy given to us by alcohol, or one of them. And this excessive NADH levels, even though it's energy, it actually can stop our glucose production, and it can stop the breakdown of fat molecules. So it's actually going to stimulate the production of fat molecules. So if you think about that, when we have this breakdown of alcohol, it's more than just the calories that's actually you're consuming in alcohol. It's actually stopping the breakdown of your glucose and actually creating fat molecules, or stimulating the production of these fat molecules. So when somebody has a beer belly, or they have abdominal fat, a lot of times it is related to alcohol. And it's not just the calories. Here's a simpler pathway of this alcohol dehydrogenase, where we have ethanol at the beginning. This is the alcohol, the grain alcohol that people are drinking. And then it has an intermediate product of acetaldehyde. And then it's further broken down into acetate by these two enzymes here. So that is a little bit clearer, a little bit easier to read. However, this diagram is going to help you do the lab. So the lab is a cutout and paste lab. That you can do just to make sure that you know this. All right, it's one of the assignments I'm giving you for this week. So I'm going to stop there. That's all you need to know for this lecture on the toxicology of alcohols. I hope you found it helpful, and I will give you a few activities to sort of bring these concepts home. This does end our toxicology lectures, and we're going to move on to another unit, probably serology. So we're going to probably talk about blood next. I hope you guys are doing really well. Take care. Bye.